Myself and Shazeb are extremely excited to share a little bit about what both AWS and Anthropic are doing to help you deploy GenAI securely at the model layer and at the provider layer. Let's get to know ourselves a little bit. You want to kick us off?
Yeah, thanks, Matt. So hi, everyone. My name is Shazib. I work at Anthropic as the risk management lead there. I'm based out of Boston, been at Anthropic for about a year. And a couple of interests that I have, I like Lego sets. I've had a chance to build a few here and there. And then I do enjoy word games all the time. So I usually try to start off my morning with my wife playing some word games. And then I'm an advanced certified scuba diver, so I've had the opportunity to scuba dive in a lot of places across the world. And then I've also picked up on this pickleball mania that's been going around the world the last couple of years since COVID. Jumped on the bandwagon for sure, but if anybody wants to talk to me about if it's a real sport or not after the session, happy to have that conversation.
Throwing down the gauntlet. I think that's a challenge if anybody wants to take him on. My name's Matt Sainer. I lead security specialists, and I have a privilege of supporting about 250 of our largest, most complex global customers across multiple industries and again across the globe, and helping them achieve their business outcomes through security solutions. Outside of the day job, I'm a general aviation pilot, so I love to be up in the sky as much as I possibly can, but other than that, I'm really happy to be here with you today. And then as a dad, my kids kind of dictate all the rest of my time. All right. So today, I'm going to give you a precursor of what we're going to go over. So what's the current state of AI safety and security? And we're really going to disambiguate the difference between safety and security, which I think is important. Heavy lifting. So what is it that both AWS and Anthropic are doing on your behalf, both from our side of the shared responsibility model, as well as what you need to then take forward on your side of the shared responsibility model? Thinking about that layered safety and security, what are all the things that are unique, nuanced in a AI world that you need to think about from a safety and security perspective? So we'll cover a bunch of those different topics. I just want to kind of level set with where are we? So end of 2022, the world all of a sudden was like, oh, this AI thing is very real. AI ML is not new, it's been around for decades, but the democratization and the exposure of that through OpenAI and Anthropic Claude kind of emerging on the scenes, and all the other big providers and AWS jumping on board this, really launched into the evolution of experimentation, productionizing those experiments, and now saying, okay, we're going further, we're going into agentic AI, we're looking at things like MCP, we're looking at how we scale this thing out. And I kind of like to use this analogy of a park. So when we think about, or a playground, so when we think about security, that's pretty well defined. We understand what that means. Safety brings another context into this. So imagine you're out on a playground, and you can see here we got a beautiful new play set in the background. It's made of materials that are less harmful than maybe the playgrounds I grew up on, with hard metal and rough edges. It's got softer plastics, and you can see the barriers there. A lot of things that keep kids safe. If they fall off of something, it's a rubber mat ground, not pavement. And then in the background, you see, maybe there's a fence, right? So you have also oversight here from two parents that are watching to make sure everything's staying safe and secure. So this is a combination of where you have these safety devices in place, and you also have traditional security devices in place. And kind of can think of that same analogy applying to the world of Gen AI and as security practitioners, where we need to balance where we do that. You want to go ahead and tell us a little bit about how you disambiguate?
Yeah, thanks, Matt, for setting the stage. So with regards to safety and security, when we think about what are the components of deploying a responsible AI solution that you might be doing for your customers or that we're providing to many of you, we have to think about safety and security together. So what does safety mean? Safety is preventing the system from driving harmful output. So encouraging accurate and relevant responses and aligning those goals with fairness and bias in mind. And so this gets very, very challenging with large language models because they are non-deterministic. They are feeding off of training data sets. And so based on that, all of us have a responsibility, even as security practitioners, to take this into account. Security goals have evolved, but the purpose of them stays very similar, right? So we have the confidentiality, integrity, and availability, CIA triad. Along with that, privacy is also rolled in for a lot of organizations. And so those two goals now, with the deployment of large language models, are now starting to converge. You cannot do a deployment without keeping both of these in mind. Now, these might not be handled by the same teams, these might not be handled by the same individuals, but as these goals are starting to merge, we need to think about evaluations, we need to think about system deployment with both of these things in mind. So how do we do that? Now, I've put up a few things on the slides. What are some safety components and a few definitions of those at the top, and what are some security components that have traditionally been there and what those mean at the bottom. And so I'm not gonna read off the slides here, but just so you can get an idea of, hey, these systems have to incorporate a bunch of these components together to get a trusted output to the user. And so we do a lot of this work on the back end as Anthropic and AWS, but we're also going to show you how do you layer on top of that to meet the obligations associated with these concepts. So we have fairness, explainability, steerability, which is a very new concept that is getting a lot of traction, which you will have a lot of control over based on the way I'm going to talk about the evaluations. And then harm prevention, safety components, and then security, governance, confidentiality, and integrity of what's coming back out. Those are components that traditionally a lot of security practitioners have thought about. So what is our approach as Anthropic on responsible AI? How do we prove that we're doing it for you? So first thing is we're guided by our responsible scaling policy. The RSP was one of the first of its kind that talks about, okay, when we deploy models, what are the factors that we're taking into account to meet these safety and security goals that we've talked to you? So our responsible scaling policy evolves over time. Every model release, we're considering based on the responsible scaling policy what we have done. The second thing is we were one of the first AI labs to receive the ISO 42001 certification for responsible and safe AI. So a lot of companies are still working on this certification. As one of the first providers, we worked with the auditors to determine what is applicable here. And so we really are proud of the fact, and our audit team did a lot of work to make sure that we're one of the first to market, as well as setting the standard for what a lot of other organizations are doing. And the last thing, and I'm going to jump into the constitutional classifiers in a little bit, but when we talk about deploying these models over to you, there is things running in the background that are based off of our constitutional AI and the classifiers we've built in there, as well as the training that goes in, to make sure that we're taking principles of ethics, legal responsibility, as well as harmlessness into account when we're pushing this out to people. So just recently with our Claude 4 Opus and Sonnet release, we just jumped to an AI safety level 3 standard. So our responsible scaling policy defines AI safety levels. And those AI safety levels are dependent on the capabilities of the model, so the intelligence of the model. So we just updated it based on Claude 4 Opus to our newest standard, ASL3. What that does is it tells you what security standards we follow internally. It tells you what deployment standards we have in place for safety. And then when the model gets more powerful and more capable, what are those triggers that will then drive us to say, okay, now we need to increase our security standards or increase our deployment safeguards. All this is to get you to a point of how do I, when I deploy these models through AWS and use Claude 4 models, get a calibration of what is my acceptable risk as a practitioner to be able to deploy these models to my customers or my use cases. So when you're trying to figure out what is my acceptable risk here, right? The first thing I would recommend is everybody should develop their own custom evaluation systems. And I'm going to give you examples that are technical around why these evaluation systems, the things that we do is also built in, but why it's important for everybody to also build their own custom evaluation systems. And these are not only for technical things, these are also for administrative process. Many of you are probably trying to automate or supplement business processes with large language models. And so it's very important to have evaluation systems that can apply to both of those. The second thing is every single provider, for the most part, is releasing system model cards. Now, system model cards tell you what are all the risks that we've taken into. So I'm assuming many of you are security or privacy practitioners here, and so system model cards, kind of think about them like SOC 2 reports, right? SOC 2 reports tell you what are our practices, who's audited against them, what is the testing. They go even deeper than that a little bit, but if you look at them, they're really going to tell you, hey, for use cases that are applicable to you, what type of testing have we done, what risks did we find, and what risks did we already solve for. And then the third thing is when you do deploy them, you have to think about the visibility and control. So I talk about developing evaluations here. When you develop those evaluations, you need to also monitor once you're deploying it. And Matt's going to talk about what Bedrock Guardrails does in a little bit to help you obtain that visibility and control when you are deploying these systems. And last but definitely not the least is you have to find out where your human and AI interactions coexist based on this risk. So if you're trying to figure out, hey, which systems are we comfortable with the AI models based on the evaluations that we've already done, based on looking at the system model cards and the risks identified there, based on what we can get visibility and control over, which parts are we okay with the model running, which parts are we okay, do we need to have humans in the loop? And so this is very, very important components for you to define as you're thinking about going and deploying these systems. Now, a little bit of a deep dive into evals. So because these slides are going to be available to you after, and I think this is going to be posted on YouTube after the fact as well, I'm not going to dive into every single example, but taking safety and security measures into account can be done by using eval systems. And eval systems can be done both pre-deployment, which is much more cost-effective and easier to do, which we're going to talk about a lot. And then you can also do it post-deployment. That is giving you real-time insights about how people are using it. So it's very hard for us to figure out all the edge cases. That's why the post-deployment is necessary. But when you look at the life cycle of developing evals, it's mainly around figuring out what are all your use cases. Every company has its own use cases. You figure out those use cases, you engineer the prompts to figure out, okay, how is the model going to respond to them? You test it, you reevaluate it, and then you test it again, and then you deploy it, right? And then monitor it. So what are some principles you should follow when you're designing evals? So eval design should be very, very task specific. So if you have controls in your systems, you have to figure out what are all those controls doing? What are the control activities that those controls are doing as well? So get it down to be task specific all the way down to each control activity. Automate whenever there's a possibility to automate. And then last is prioritizing volume over quality. So if you're sitting there trying to write the perfect eval, there's always going to be edge cases that you're going to miss. It's just natural, right? And so users have ways to change their behavior on these systems depending on what the models can do. And so if you prioritize volume, it'll give you a much better insight over how these evals are done. Now, once you create the evals, you have to grade the evals. How do you grade the evals? Grading the evals, there's three big things. Code-based eval grading, which is very binary, right? So you can say, okay, did the model output X? If it outputted X, run the formula, check if it's exactly what is matching, right? Then there's human grading. This is very expensive, but for very, very high-risk use cases and very high-quality use cases, this might be possible. And LLM-based grading, now that we have multiple model systems in place, so you have Claude 3 Haiku that can do LLM-based grading of the results coming out from Claude 4 Opus. This can get very, very scalable very quickly. And so because the LLM can kind of grade itself based on your use cases, this is actually a very, very good way to be able to scale your evaluations and change them as the model capabilities change. So now, how do you use these evals to apply security controls? So jailbreaks are something that you've probably heard a lot about. Prompt injections is another thing that you've probably heard a lot about. So how do you use evals to reduce jailbreaks and prompt injections? So you can do things like harmlessness screens, where you use a lightweight model like Claude Haiku to pre-screen the user inputs. And so this is when it's coming into you, right? The second thing is input validation. So this is similar to the first one, but this is specifically filtering them, not just screening them, but filtering them for jailbreaking patterns. So there are open source jailbreaking tools out there that you can use that show you what are the patterns that you might want to be concerned about. We've built a lot of jailbreaking defenses into the models already, But if you see something specific to your case that you're really, really worried about, you can use that to do the input validation. You can even craft prompts that emphasize ethical and legal boundaries. So I talked about our constitutional classifiers a little bit where we're doing this, but you might have your own legal and ethical boundaries that you want to consider as you're deploying these. You can craft the prompts to do that. Oh, sorry. And the last thing I talked about is continuous monitoring. So jailbreaks, whenever you see jailbreaks come into the system and the classifiers you've already built help you detect those, you can have that monitoring in place to alert your teams to then say, hey, someone is looking at jailbreaking. You can either respond back to them or just have it as an alert to follow up on after. I'm going to dive into number one a little bit and show you a technical example. So what is a harmlessness screen? So since this is a 300 course, I'm not going to dive into what user assistant and prefill does. I'm assuming as practitioners you might already know that. But if you don't, feel free to come up to me after and I'll explain what these mean. But in the user prompt, when you're putting in for content moderation, you can actually ask the prompt, you can actually ask the model to ask and say, hey, if you see this being harmful, and because we've built harmfulness and harmlessness into the model, it can determine this for you. So if you see harmful, illegal, or explicit activities, reply back with the no. Now, you'll see the parentheses and the brackets here for one main reason is you want a binary output. In this scenario, the model will give you a binary output. We're used to seeing, okay, models will give you sentences and sentences of information back. But if you want to prompt it to say, I want a binary output based on you analyzing this, you can prefill and put the assistant in this way. And so this parentheses here will really drive the model to say, hey, give me only a binary output. So then when you get the N or the Y, you can then use that as a screen to then say, okay, I'm going to give the user back a response, or I might just say no to the user and just shut that conversation down immediately. So that's an example of a harmlessness screen. The second security control I'm going to talk about is prompt leaks. So a lot of us are worried about, hey, the data that we're giving to these prompts, how do we make sure that that doesn't get leaked out to the system? So the first thing is to separate the context from the queries themselves. So if you think about how we do like SQL injection attacks, right? This is very similar to that, where you say, hey, for reducing the capability of the model, we don't actually use the response back in the query that we're giving back to the user. So I'll show you an example of how we do that. You can also use post-processing to then determine if the words, like if you think about like a DLP tool, right? How a DLP tool does like screening of specific key terms and words before it gives an alert. You can do the same thing for post-processing of the model's output to then say, okay, if you see these specific words, remove them before they're going out to the user. And the last thing is avoiding unnecessary details that the prompt might not need. So when you're generating the prompt, it's very easy for us to say, let's give it everything it has and then let it make the decision, right? Sometimes that is not the best case. So think about what it needs to make the decision and only give it that. And the last thing is we're generating these prompts all the time, right? Developers are generating them all the time. For high-risk use cases especially, it is very important for us to say, okay, we're going to just audit the prompt. Model capabilities might change. We might have gotten alerts on systems that we're taking into account. Let's just do a quick audit of the prompt to just make sure it's still meeting these obligations. And you can use this as a concept of a checklist. So how do you separate the context from queries? The example I'm giving is an analytics bot that is doing EBITDA analysis for a financial services provider. So you, as a financial services provider, might have a very proprietary formula that you use. Now, EBITDA calculations are not proprietary, they're very common. But imagine if you had a proprietary formula for generating something that you're trying to give back, right? How do you make sure the model doesn't give that formula away to the system user, but you still want it to be able to get the results? And so the way you do that is for the system, you tell it as a job description that your job is to analyze based on the EBITDA requirements. The next thing is in the system prompt, you tell it, never ever give the proprietary formula away. Then in the user prompt, you can again say it to say, here's what the user is going to give you. Here's your job to calculate it. Again, never give the formula away. And then the last thing is, again, in the assistant prefill. The prefill is instructions for the assistant as it's formulating the response. And if you put that in brackets there, the assistant knows that this is context and not to give it back to the user. So that's 3 separate places you can put in the context separate from the query, because the assistant then is going to give that back to the user. So you're only giving it the formula in 1 spot, but you're telling it never to use the formula in 3 spots. And the last one I'm going to talk about is a safety control. So we talked about security controls are important. Safety controls are just as important. How do you use hallucinations? First thing is allowing the model to just say, I don't know. Right? Just how we want to do it for humans, and to have the capability to say, I don't know when you don't know something, don't make it up. You can tell the model to do the same thing. Use direct quotations from factual groundings, which can be used via citations. So citations APIs are available for our models, and you can say, hey, based on either your RAG or your systems that your system context, always give the citation before you give the response back. And then again, you can do a screen to determine if it gave the citations. So how do you tell the model to say, I don't know? The way to do that is, again, in the user prompt, possibly not the system prompt. In the user prompt, you can tell it that, hey, this is your responsibility, and find the details based on XYZ formula. And if you cannot figure it out based on this formula, just respond that I don't have enough information or I don't have the context to be able to solve for this. So that will then help you reduce the hallucinations, and it won't go out and try to find sources that are not applicable to the system. So again, you saw I gave you 3 to 4 examples of things you can do, but then I only dove deep into 1 example. There's way more security and safety controls that you can customize. You can look at docs.anthropic.com to see a lot of these. I pulled a lot of these directly from our help center. And the second thing is Matt is going to talk a lot about guardrails on how you can build some of these into there. Matt?
Thanks. So everybody's probably familiar with the shared responsibility model, or the SRM. I kind of mentioned it as we were kicking it off, but the important thing to call out here is what we are doing on our side of the equation, the collective royal we. And I've kind of modified this just slightly to indicate that at that software layer is kind of where we're thinking about that LLM. What we really need to be thinking about is not just our generative AI application, but the full piece of the iceberg, right? The part underneath it that's really our data foundation, and making sure that we're thinking about that safety and security aspect there. So at AWS, we think about this in a 3-tier model. So I want to kind of go through tier by tier and give kind of a little bit of examples of what we're doing to help keep you safe and secure. So first, let's start at the lowest layer, which is really infrastructure. And the first thing I want to highlight is not a Gen AI specific storyline here. It is just articulation of what we're doing at the scale we're doing it, which is just incredible. Working here or not, I just can never get past these numbers and the scale that we operate. But you can see the amount of data that we see and process, and the threat intel that brings in is directly correlated to what we're able to provide and protect our customers with. So we've talked a little bit about some of these underpinnings over the last year and a half or so. MadPot, we heard in the keynote from Amy and team. This is a honeypot on steroids, if you will, that allows us to kind of see what threat actors are doing in the environment, use that intelligence to keep our customers safe. Mithra also does this, but does this in a sense of DNS and other domain-centric callouts, what's happening there to protect and protect people. And as we mentioned, again, the keynote, if you call back to that, this data is potentially something that needs to be updated in seconds, not minutes, hours, days. And then also, how do we prevent attacks, right? So again, through various threat intelligence channels, looking at how we use capabilities like Scenaris to protect our infrastructure proactively and protect your infrastructure proactively. All that threat intelligence feeds into our core native security service capabilities. We do not release products or services, whether it's Bedrock, SageMaker, et cetera, unless we can meet the very high bar of security and enablement there. And so when you are deploying these tools, you are also inheriting that ecosystem, if you will, of capabilities underneath the covers. Second thing I want to call out is Annapurna Labs is our hardware arm. And we basically build all our own silicone. And when you do that, you can control the supply chain, right? Both at the software level and at the hardware level. And that's really key to being able to enable things, which I'll talk about next, like Nitro. It also allows you to think about how do you have encryption all the way into that hardware enabled layer. So let's talk a little bit about Nitro, right? So Nitro is a specialized hardware. It sits outside of the Linux kernel and allows us to create isolation that restricts operator access, right? This is provides secure boot environment. It's hardware based. You can see in our compliance reports and attestations that this is validated to protect our customers from keeping their systems highly isolated. And again, this is something that you inherit when you build on top of. Now, I'm not going to go into deep detail because there was a great session by some of my colleagues, JD Bean and Jason Garman, at reInvent last December. It's on YouTube as well. There's the link to watch that, as well as a great blog more about securing our AI infrastructure. So where I'm going to spend the majority of the remainder of our time is in that middle tier. We're going to talk a little bit about Bedrock. So I think you want to go ahead and take this section?
Yeah. So as Matt jumps into Bedrock, when you use models at the software layer, there are protections that are already built in from the model side for prompt and inference. And so for training, what we are doing is in training, we're using diverse data sets. We're doing a lot of reinforcement learning to make sure that it's helpful, harmless. And then the last thing I talked about is constitutional AI. So this is happening at the training layer. And then after the training layer, the eval layer, which I talked about a little bit, we're already doing a lot of evals on your behalf. So we have internal red teams. We have capabilities associated with our responsible scaling policy that we test against. And we even have external testing partnerships with things like the US AI Standard Institute, as well as the UK AI Safety Institute, and biolabs, and CBRN providers. And so we have a lot of these partnerships where we're building a lot of this into the model for you. And then when you're deploying, we actually have classifiers that are evaluating the inputs, whether you're doing it through, even if you're doing it through third-party APIs, such as Bedrock. And those are screening for harmful and harmlessness for you as well, and giving you indicators back. So when you get those indicators back, Matt's going to talk about what you do with them in Bedrock, but we're doing a lot of that indication for you. And last thing is, even after you deploy, for this industry to continue to get more responsibility around how we're deploying AI models, we're looking at feedback and policy as well. So our RSP is not just for us. We're hoping that it's helping increase model capabilities throughout the software stack. And then our testing feeds into our usage policy and the model training back. And then the last thing is we do a lot of research to say, hey, how is we have societal impacts teams that are determining, hey, when people are using our models, so you all might have so many different use cases that you use the models for, you want to see, okay, how does this actually impact our business users across our entire system? And things like our economic index report can tell you a lot more about that to say, hey, people are using it in these ways, think about the risks from that context, and then build that back into your eval and training. So I talked about during training, we have this concept of constitutional classifiers. When constitutional classifiers was released by the company, it was named as one of the 3 most important AI innovations in 2023 by Time Magazine. And the reason for that is because we're building it into this entire pipeline like you're talking about. So I'm giving you an example of how we're building these systems into our pipelines. You also have the capabilities to build them into yours. So the way constitutional classifiers work is in training, not only do it tell it what's helpful and harmless, we also tell it what is not helpful and harmless. So just like you need to give it the light, you also need to show it the shade so it can see the light better. So we give that in the training data sets. Then we go through the loop during the training set generation, where we're asking the model to provide examples to itself to say what is harmful and what is harmless. And then when the examples are coming in, is pushing it back into its training data set. So it's reinforcing that learning of what is harmful and what is harmless by going back into it. And then the last thing is when you go out and you deploy this, that constitutional classifier is constantly running to then determine, okay, on the input, right, when the user gives it, you do a screen at that point as well, and if it says, hey, no, this is not an honest question, it might screen it out at that point. But not only is it looking at the user input, then when it spits when it gives the response back out, it is also looking at its own response to see if it's meeting those constitutional classifiers, because that is new data that is now being generated. So that whole loop is super important for us to capture. So we're showing you how our classifiers do this. You also can look at how you can build your own classifier systems using the evals that I provided earlier to build this for yourself.
Thanks, super powerful, Shazab. All right, so one thing I want to kind of lead with here as we get further into the Bedrock story is the data privacy aspect, right? You are in control of your data. And we start with having zero customer data used to train our Amazon first-party or third-party models. As your data, you own it, it's not used to train models. Second is your prompts and your completions are your own, right? These are not something that are shared or seen by Amazon or the providers. And third, no customer data is exposed to humans or human-in-the-loop operators for abuse detection. All that is completely automated behind the scenes. So to go a little further on this, as I mentioned, never shared and not stored. Also, if you have region requirements where data needs to remain in region, wherever you call those inference and prompts, stay within region to meet your compliance and geographical region needs. All data in flight is always encrypted. If you saw the keynote again, you saw that's actually multiple layers of encryption. We don't just, from a defense and depth perspective, we believe that that encryption is important at multiple layers, and you can use your own KMS keys to manage how that data is stored. We also expose everything's an API at AWS, right? Everything's an API, so you can use CloudTrail, you can set up CloudWatch and metrics and alerts. You can observe through Guard Duty and Security Hub. I'll talk a little bit about that in a bit as well. And then, and for those that have specific compliance needs, we are building that out. There's 20 already that have been completed. You'll continue to see that number grow, and we work backwards from our customers that tell us which ones of those programs are the most important to enable them to deliver. So I want to dive in a little bit into a typical Bedrock data flow. Of course, any organization might build this slightly nuanced or differently, or add additional complexity or points into this. But if we just think about this as your own network, your own VPC, and then the Bedrock service account, this is kind of the starting point. So you could hit that API endpoint, which, by the way, we have FIPS endpoints as well, if that's something that you need for your business. You can hit that directly from the internet, or you could obviously come in through a private link that hits the API endpoint over like a direct connect or VPN or however you might get in through into your VPC. And then that API endpoint uses the orchestration layer that's in that Bedrock service account to then do the inference on the model. That model actually is sent to Amazon through the model provider, so they have a model staging account. That model is then replicated where the model where the model provider, such as Anthropic, doesn't have access into the service-owned and managed and operated account. So that allows that segregation to occur as well. And then finally, all of these capabilities are built on top of our base core security service capability. So we have identity and access management policies that allow you to control very specifically how to invoke models, Bedrock guardrails. I'll give a demonstration of one of those in a moment, along with all the other aspects I mentioned around CloudTrail, et cetera. So when we think about inference specifically, what does that look like? So there's a few things. Again, I'm going to reiterate this. No logging customer data. It may sound repetitive. I just want to make sure that we're hitting that point home. Your data is your data. If you choose to log it and you choose to turn on prompt and output logging, you can do that. And a lot of customers do that because they want to have their own internal QA to see like how their applications are working and tune that over time. There is no modification to deployed models. Those models are essentially static. No outbound connections from the host. So this is something that was a pretty popular question a few months ago as additional third-party models are available, or you may host models. Within Bedrock, there are no outbound connections, right? So the only thing that interfaces with that model is the API and what you call into that API to pull back with the output. And all inference is actually segregated. So in terms of being able to have any kind of inference kind of in the environment, it's segregated to your specific calls. There's no caching of data, right? It's stateless in that sense. And I want to move on to the model evaluation piece. So we talked a little bit earlier about some of the ways to think about doing model evaluation and some of the mechanisms that you can implement. And Bedrock has created a variety of tools and capabilities for you to do that. So we talked about when do you use programmatic, when do you use human. LLM as a judge was something that we had launched previously in preview and is now GA. But these capabilities help you, in a sense, figure out how do you do model evaluations, whether that's you want to evaluate a different model provider, whether it's you want to see what the latest version is, and then you can then correlate and compare those across those and understand what's going to be working best for your business and your use case. In addition, you're seeing these kind of evaluation strategies also apply, not just at the model layer of the stack, but what does it mean when you're using retrieval augmented generation and pulling in data to augment your prompts, or further in agent evaluation. There is a AWS samples project out there that you can see, and an open source project around agent evaluation. And as agentic AI continues to accelerate and take off, you'll see a lot more in this space. So let's go through guardrails here. Guardrails, again, is one of those things that the overlap and convergence of safety and security can be seen. Several of these are purely safety, some of them more on the security side. But what we want to do is give you control and our customers control over what really happens as a shim against any given model that you may choose within Bedrock and beyond Bedrock. So if you have self-hosted models, you can use it there as well. So let me talk a little bit about how this works. So you'll have a user input. And as I mentioned, there's kind of two ways. If you're invoking a model through Bedrock, you can do that. Or if, let's say, you're hosting a model in SageMaker, you might want to do an apply guardrail there. Or in your own self-hosted model, you can still use guardrails. The user input goes through that API call into one of the policies within the guardrails, and you can see them here. I'll go through them in a minute. Then it uses those and through the inference to say, okay, now I've got my input guardrail policy. What will I send to the foundation model? The response comes back, goes back into an output evaluation within guardrails. And then if that guardrail also passes, the final response is then sent to the user. I mentioned earlier the enablement of several of our capabilities. So this is a good example of a condition key within identity access management, where if someone is trying to invoke a model, you can now enforce and ensure that the guardrail is in place. If they try to do it without passing that guardrail ID, that call will be denied. So I talked a little bit about path one, which is if you're using Bedrock, the guardrail invocation is kind of directly integrated and easy to use and easy to call with the invoke model. However, if you choose to self-host or you are using an LLM of your choice, maybe in SageMaker, for example, you can use the apply guardrail API and essentially make sure that it'll do the same rule processing both for prompts and responses. So I'm going to go through these at a relatively quick pace. We have a lot of great content, both in the documentation and other presentations, that spend the entire time talking about Bedrock guardrails, and I want to cover a broader ground. But I'm going to start with the content filters. these are kind of sliders for these categories that you can then evaluate, like is the response both input or output hitting either of these any of these kind of capabilities, and then you can tune it up or down. And as you can see here, you can test these. And when you test them, you need to make sure that you're actually thinking about what are the use cases that your user is going to be using, and then also threat model, right? Threat model your applications, apply the threat model, understand how that might impact the way you build out your guardrails and test your guardrails. Prompt attack detection is more on the security side of the equation, right? As we think about other traditional prompt injection attacks, SQL injection, command line injection, same kind of thing here where we think about the prompt injection for LLMs. And this is kind of one of those, based on threat intelligence, based on what we learn, this becomes smarter and smarter over time to help protect you. Multimodal toxicity detection is how do we take text, how do we take images, how do we take a combination of the two, and then use those to determine what we filter in or out. So I am going to show a quick demo on this one where, click it, let it play here. So we're going to pick a model. I don't know, maybe Claude sounds like a good one. I don't know what you think about that one. We'll pick Claude. And we're going to upload an image. And if you look here, I've got a couple. One is, that's pretty violent, but maybe this one of some kids just scuffling on a playground. What might this look like? So we're going to do the testing, as I mentioned earlier. We're going to evaluate what would a model do here. And so we say, hey, can you describe this model? And it basically says, no, I can't really do that. So now I want to inspect. I want some explainability. What's going on here? So it's telling me that the strength of this is high. At a confidence level of medium or higher on that scale is going to block it because it looks like it fits the violence category. Word filters, these are pretty basic in terms of like, I want these words to not come in or out of my foundation model. So pretty prescriptive. Denied topics are kind of cool. This is where I can give it a prompt or a context, and I can say, don't have conversations, don't have outputs if it fits into the spirit of what I am telling you to look for. So this is where kind of LLMs helping you solve the guardrail problem in and of itself. And then PII filtering. This one, very popular, very commonly implemented, especially in specific industries, healthcare, life sciences, for example. We might have PHI or PII data that you need to redact. And you can change this to either just detect it's being used, redact it, or filter it entirely. You can use the predefined filters or also customize there. And then now we want to talk a little bit about hallucinations, because this is obviously something that people are very cognizant of. How do we minimize, mitigate, reduce the odds of hitting hallucinations? So if we have contextual grounding checks, what contextual grounding checks do allow you to basically use RAG and kind of verified answers to check the accuracy of the responses. And then if those responses appear to be correct and relevant, minimize the ability for that to potentially return a hallucinated answer. And there's you can change the grounding threshold for that. That allows you to kind of say, hey, how does it validate whether that is a correct answer or not? And then the relevance of how closely aligned is that to the returned response. You can, just like firewall rules, you can determine whether you want to block entirely or whether you just want to detect. This way you can, before you formally implement a rule, kind of test it out, see if you got it tuned right. This is very helpful when you're building these things out or evaluating these over time. And as I mentioned, you can do it on inputs and or outputs from the model. So one thing I want to show that's currently in preview that I think really is a game changer. So we have the contextual grounding, but automated reasoning is a capability that we use for access analyzer, network analyzer. It basically, you could take a near infinite set of potential possibilities and then using mathematical proofs define a binary output of 1 or 0 or yes or no, and understand whether that outcome could potentially happen based on the way you're doing policies. So our AWS kind of leads the field in this area of data science, and they've applied this now to automated reasoning. And what this allows you to do is build a set of policies in variables, and again with the foundation model and underneath the cover that actually helps you build those. I'm going to give a demo here of what this looks like. But before I get into the actual demo, let me show kind of the workflow. So let's say I had a policy, and the one I'm going to show you is an HR policy for leave of absence for employees, and I want to do automated reasoning checks on that. So I put it into the automated reasoning check. I say consume this policy. It's going to output what it sees as variables and rules. It's then going to feed that into the guardrails, and we're going to have a QA process to validate that. Are the variables and rules accurate? Are they complete? Then we're going to actually implement that as a guardrail, and then as the next prompt comes in, it's going to apply what we built and evaluate it back into, and then feed that back into the guardrail. If it says yes, that actually, the statement that is returned from the model is accurate, it will give it a thumbs up. If not, it'll say no, that's not accurate, and deny it. And if it's accurate, it'll continue to pass it back on to the user or the calling system. So here's the demo. And going into the automated reasoning screen here, I'm creating a policy called leave of absence paid. And you can see this is maybe the policy as written by HR, and it gives a lot of details of what that policy looks like. And I'm going to, just like anything, create an intent here, create kind of an explanation of what am I trying to do? What is this guardrail ultimately trying to do? And I want to explain that if employees ask about eligibility for the program, make sure that they can understand what is their eligibility for this. So the only thing I've done in this whole demo is I cut out about 30 seconds of video there just to accelerate this, but that's as long as that took to populate, and you can see policies up top, rules up top, followed by potential variables that it could extrapolate from there. So now I'm in the test playground, and I want to say, hey, what if the question is, I'm a temporary contractor, am I eligible for a leave of absence pay? And let's say the model said, yes, temporary employees are allowed to use LOAP. This is saying, well, that's not a valid response because the extracted variables down there that I think align to the way and the intent of the question were these specific ones. And I can go in as I'm doing that QA aspect and say, okay, let's expect that the level of the employee will be explicitly mentioned in the question. If not, then that needs to be part of how the response is formulated for it to be validated. It'll version these, so I can always go and see how am I modifying this over time, the life cycle of these policies in variables. And so this one here, variable saying if it's less than 20 hours a week, that is not a full-time employee and therefore would not be valid. So now I'm going to say, hey, I'm temporary, change temporary to I'm a part-time contractor. And see if the answer stays the same. I'm explicitly defining that answer. The validation result comes back as invalid. And then the description here, it kind of gives you the explanation of what's actually happening within this particular guardrail. So I'm waiting for it to go to the next example of the demo here. This is just showing kind of how those variables are formed. Now I'm actually just wanting to create the guardrail. So now that I've tested the guardrail, I've created the policy based on those rules and variables. I'm just configuring the guardrail. It's actually pretty straightforward to walk through the GUI and the wizard here to create the version that I want this guardrail to run against, implement the guardrail, and click create the guardrail. Now it'll give me a guardrail ID, and that's the guardrail ID that I can then reference and use from there forward. So I'm really excited about how that evolves and goes to GA over time. So I want to just kind of cover here real quick several of these controls in in Bedrock guardrails span between deterministic and probabilistic, right? And this is something that, as we think about that non-deterministic way that models produce their output, we're also thinking about how does that impact the way that we set these guardrails up, set these rules up, and how can we actually use that to our benefits? Where do we need to be explicit and deterministic? Where do we need to be probabilistic? Or where is it a hybrid of the two? But what we've seen by implementing these guardrails is over an 85% additional improvement beyond what you even get out of kind of base models. Obviously, folks like Anthropic are continuing to do a lot of work to make sure that models eliminate hallucinations, eliminate harmful content, and that gets us a substantial amount of the way there. This is one of those defense in depth and layer control capabilities that helps add that additional layer and make sure it meets your specific organization's expectations and needs. And so we really encourage folks to, if you're using Bedrock, to definitely learn how these guardrail capabilities are going to help you on the safety and security side. Right. So you can't go anywhere without probably this conference without thinking or talking or hearing about agentic AI, and so we wanted to cover that topic a little bit. I think if you break it down into a very simplistic thought model here, we're thinking about how do you take these specific agents that have the ability to have memory, leverage tools on you or a machine or a workflow's behalf, and ultimately achieve these goals. But at the same time, we need to have high degree of observation, high degree of control, high degree of identity context that flows through these, and really understand that end-to-end environment. So just like we had the stack for how we think of Gen AI services, we also are thinking about how do we think about the agentic AI stack as well. And this is at all layers, whether you're building your own agents, you want to deploy agents that are based in here, or whether you're consuming something like Q. So MCP is a great emergence that I think was created back in November or December timeframe. We're continuing to partner really closely with Anthropic and others to continue to build this out and enable customers to use this securely. But I think, would you like to talk a little bit about what Anthropic's done about the MCP?
Yeah. So a little bit about how the concept of MCP works for those that might not be familiar with it. So you have kind of three layers in the stack when you're thinking about an agentic AI. So you have the MCP client, which is whatever application you're building. You might have your integrated development environments. Might have your business analytics tool. Now this new layer has kind of stood up in the middle that wasn't there before, which is the MCP servers. So Amazon provides ways for you to build your own MCP servers. You can build them yourself. There's open source tools out there to do that. But each use case might have its own MCP server. And that MCP server then connects back to the sources of data that exist. And so you might have a lot of use cases that these MCP servers might be serving. Now, how do you protect them? These are still pretty new capabilities. And so there are a lot of best practices that you want to make sure that you follow when you're thinking about having your agents that are getting work done using MCP servers. So the first thing is connecting only to trusted servers. A lot of companies are building them out there. A lot of spam MCP servers are also popping up. So as you're thinking about which ones do we want to connect to, look at the trusted environments to make sure that they're hosted by organizations, as well as the underlying infrastructure for those servers is taken into account. The second is we've seen a lot of issues where you're generally, these are all run via APIs that are talking to each other, right? So permissioning models are really, really, really important here. We've seen incidents happen with this. We've seen challenges by companies who just can't figure out how the APIs are interacting. So you have to be very, very careful on generating the right API services and the permissioning models when you're creating these servers, and then test them very, very well. Like you don't want that service to connect and give data back that it's not using. Those evals that I talked about around context and queries being separate, those get very, very important here. And then be aware of prompt injection that can come in. So MCP servers are servers like no other. They have libraries running on them. They have connections and network connections built in. So if you are looking at prompt injections into those MCP servers, someone might be able to say, okay, now there's a third layer that is built in before it even connects to the data store that is storing data there. And so they're going to try to inject information in to see if it can use library changes or injection-based attacks into there. And then the last thing is monitor the change in the tool behavior. So if you connect new services to that MCP server, if people's use cases are changing, monitor that to then make sure that it's only leading to intended outcomes. And then last is build it to handle your scaling requirements. So MCP servers, as soon as they're built up by a lot of companies, hundreds and thousands of organizations are starting to connect to them. It's very hard to scale these if you're hosting them yourself, so looking at Amazon with auto-scaling rules is really important, as well as making sure that as they're scaling, the permissioning models don't get messed up as well. So those are things very important to handle. So you can use this as a checklist when you're building an MCP server to make sure that all of these are taken into account. The first one is only about MCP servers that you're using from others.
All right. Shazeb mentioned earlier that Anthropic was one of the first AI lab providers to achieve ISO 42001, and we were the first major cloud provider to also do that. And I think the important thought process that when we think about compliance is working backwards from what you expect of us to do for you and on your behalf, and working closely with these organizations that drive these compliance programs out. And so again, you can see a variety of the ones that we currently support, and this continues to grow based on your feedback. The other announcement that we just had recently was having these two models approved for FedRAMP High and DoD IL45 approval in GovCloud. This was just announced last week. And beyond that, we aren't just solving this just for our customers. We are also active contributors to many open source and open projects out there, along with Anthropic. I know Anthropic sits on COSI, for example, with us, which is the Coalition for Secure AI, Frontier Model Foundation, and obviously most people have heard OWASP, both from consuming and contributing, as well as Agentic Community, which just spun up. I know there's an MCP project that spun up as well that we're a part of. So very important to make sure we're raising the tide for all boats, as we used in our opening title. So I did want to talk a little bit about some use cases, and these can all be kind of seen. I got the QR codes here, all publicly available out there. But the London Stock Exchange Group has looked at how to use both Bedrock and Amazon Q to enable them to look at post-trade analysis and other opportunities to enable their trading desks and analysts. And you can kind of see here the way that they have built that to primarily be through interface with Q that's ragged back in with their knowledge base, and then having Bedrock that actually comes in and allows them to look at some of the additional analysis of how they're using their responses. So they are kind of like in this multi-layer approach of how they're using Gen AI in their specific use case. And we see other organizations, especially financial services. I came from financial services, and one of the things that is kind of interesting to see is they have such deep security infrastructure, and plumbing has kind of enabled them to accelerate when they've evaluated these and launched these into production over time. So we continue to see insurance companies, stock exchanges, critical other use cases around financial services, and others as well. I know these are a few of the Anthropic use cases out there that you can check as well. All of these are also built on Bedrock using Anthropic models, so you can check those out. And I threw a few fun ones in just as well. It doesn't always have to be the big, giant, serious use cases. There can just be kind of interesting use cases, interesting models out there. So check these out. Some of these folks are working on changing the world or just making life a little better for the average human, and really interested to see how they're using Gen AI to achieve those outcomes. So as we wrap up, just a couple of quick key takeaways. AWS and Anthropic are working really hard to keep you safe, and it's our #1 mission at AWS. It's our top priority. We think about it first, we think about it last, and everything in between. We deliver comprehensive capabilities at all layers, on both sides of the shared responsibility model, so not only keeping you safe, but enabling you to understand and what controls you can deploy and should deploy to implement safety and security. And again, make sure you understand that shared responsibility model. Make sure that you have the opportunity to look at some of the patterns that we publish. If you have opportunity to reach out to an account team, if you have one, they are more than happy to bring folks in to help you dive deep into this topic more. We really appreciate your time today. Really hope you've had an excellent conference. On behalf of Shazeb and Anthropic and AWS, thank you so much for being here.